Good morning, good afternoon, good evening. Here we go. On to example number 8. I think this would be our last example, and we should be good to go. So check this out here. We need to now learn a few properties about natural logs, which we kind of talked about last section, again, which is a logarithm with a base e. And it says use the properties of natural logs to rewrite each expression. And you're going to find right now that these properties look exactly like the log properties. So natural logs are exactly like the regular logarithm. So let's do our first one here. If we take the natural log of 1, that's always going to be 0. And let's see if we can make sense of that. And I'm just going to put my arrow here, and that just means like, well, that implies this, right? I mean, that's the reason why that the ln of 1 is 0 is because if I rewrite this, okay, rewrite this as an exponential form, okay, this right here, this ln has a base e right here, so that's e to the 0 equals 1. So what's e to the power of 0? 1. And so they're going, and so that's why it's going to be equal then to 1 then, because e to the power of 0 is going to be equal to 1. So this is what you got to know right here, that the ln of just 1 is always going to be 0. The second property of natural logs is that if you take the ln of e, this is pretty interesting here, if you take the ln of e, that should be 1. And you're like, well, how do I know that? Well, look, well, that's because this. If I rewrite this as an exponential form, that means, what's my base right here? E, right? So e to the 1 equals e. Doesn't e to the 1 equal e? Yes, Mr. McCaffrey. Oh, well, right, it does. So since it's equal, then it should make sense that the ln of e, or the natural log of e, is 1. Okay, so this over here on the right is just the justification for this right here. Okay, so really, all that you're supposed to know is this right here. This is really what what I want you to know for the rules. Know that the ln of 1 is always 0, ln of e is always 1. And look though, but if you can't memorize that, which I'm not trying to have you memorize all this stuff here, that's why you do what I'm doing on the right. So you say, what is the ln of e? Well, come over here, and I say, okay, well, I know this is e right here. This is my base e, so I do e to the power of 1 equals e. Oh, so that means it has to equal 1 then. You see, so that's kind of like what I'm doing over here is the reason, or how do I know this is correct on the left? Because of what I'm doing on the right. All right. Looking at the third, let's see, the third property is if I take the ln of e and I raise that to the power of x, okay, what do you think that's going to be equal to? That's going to be equal to x. How do you know that? Well, look right here. Again, if I want to know, I'm like, how do I know that equal to x? I turn this into an exponential form. So my base right here is e. So e to the what equals e to the x. Doesn't that make sense? This is true, right? So that means that must be true. So we can say now that ln of e to the x is just going to be the exponent right there. And then number 4, last but not least, if I take the ln of just x then, and I take the ln of another number y, it's just going to be that x equals y then. Okay, and that's just because if you do the same operation on both sides, like if I divide by the number on the same side or multiply by a number on the same side, then that means it's just going to be that same number right there. So that's why we can just say it's going to be x equals y. So here are the 4 rules that you have to know, and we're going to go ahead and use our rules there. So there, and all the way out to there. All right, so let's actually go and do these examples. All right. Let's see here. So I'm going to scroll down a little bit. So let's see if we can use our rule here. What's the natural log of 1 over e? Okay, so think about that there. What's the natural log of 1 over e? Okay, well, let's see. We know that this is the same thing as the ln of e to the negative 1, right? Yes, we know that right there is true. So my question, I'm going to erase this real quick. So that means then, so check this out. That means we can use this rule right here. If this is e, then we know that our answer is just going to be negative 1. Okay, but without memorizing something, you should know that this is, look, this right here means this has a base e, right? Let me tell you guys something real quick. If these two are the same base, you can just cross these guys out, and then all we have is just -1. That's kind of like another way of thinking about that. Okay. How about this right here? This is pretty interesting. If I have e to the power of ln of 5, or the natural log of 5. Let me show you something a little cool here. See right here? This right here has a base e, right? If this base right here, e, is the same as that base, we can just go like that, and it's just going to be 5. Okay, and we're using, once again, this property then, like right here, okay? Going then right here, 4 times the ln of 1. Well, we know that the ln of 1 is 0, right? So this is 4 times 0, which is just going to be 0. For 0, the hero. And last but not least, 2 times the natural log of e. We know that the natural log of e right here is 1. So this is 2 times 1, which is then going to be just 2. And so there's just a few little examples of using our properties of logarithms.